Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you subnetting with different sized subnets. In my previous video, I have explained you subnetting. But if you have seen that case in which what I have done was, I have bisected complete network into 4 sections, but those 4 subnets were having equal size. Now in this video, I'll do subnetting, but in that if you observe here, size of subnet that is not equal, it is having different size. And in this video what I'll do is I'll explain you how we can bisect network with different size, as well as at last I'll explain you how internal router will route frame for given variable size of subnets. So this video will be quite interesting. You just see this video till last. At last you will get to know like how exactly computer network is subnetted with variable size, right? So here let me read the question first. See, do the subnetting as per 4 subnetworks S1, S2, S3, S4 for given network. So this is my given network, which is what I'm going to bisect into 4 subnetworks S1, S2, S3, S4. See, here size of S1 is half of complete network. So S1 size, that is half of complete network. S2 is 1/4 of complete network. So S2 is having size of 1/4 of complete network. And S3 and S4 is 1/8 of complete network. So S3 and S4 that is having size of 1/8 of complete network. Here one of the IP for the given complete network is 95.12.55.28. So for this IP, we are deal with to have subnetting. Like you see, this is the IP which is there for this entire network. Like it could be one of IP of this entire network, right? So first of all, we need to identify what is this network. So let me write this IP first. See, this IP is 95.12.55.28. So first of all, we need to understand what is this IP. If you observe first octave, so first octave that is having value 95. So as if first octave is having value which is there in between 0 to 127, then you can say that belongs to class A. In my class full addressing of IP, I have explained you how we can identify class, right? So with class A, IP ranges in between 1 to 127, right? Here I have written 126. The reason is 127 is reserved. But 1 to 127, first octave, that belongs to class A. So you can say here the IP which is given for this network that belongs to class A, right? So this IP that belongs to class A. Now when it comes to class A, you should know some basics. Like you see, with class A, first octave that is network ID. First octave that is network ID. And last 3 octaves that is there with host ID. See, these are the basic information that you should know. With class A, first octave that belongs to network ID and last 3 octaves that belongs to host ID, right? And as per network ID that is having 8 bits. See, octave means 8 bits. So as per network ID that is having 8 bits, you can say it is having mask that is as per 8 bits. So /8, that kind of IP is this. /8 means what? With this given IP, mask is having size of 8 bits. I have explained masking even in my last video. If you observe how subnet mask is there. So subnet mask that is having 18 bits over here. How it is coming? So 18 bits that comes based on network ID plus subnet ID. So network ID that is having 16 bits and subnet ID that is having 2 bits over here for this particular case. So /18 that is mask of particular IP. And you can write that even in this form, right? In this form where 18 bits means what? First 8 bits that could be 11, right? So first 8 bits 111 means 255, then second 8 bits 111 means 255, then next 8 bits, next 8 bit that is having first 2 bits that is 11, so 11, then all zeros that is 192. See, that is how also we can write subnet mask, that is also referred as /18. So here with class A, you can say it is /18 kind of network, right? So that is what mask of class A. Now here there are few basic information that you should know, like with this particular IP, what will be network IP? With class A, what will be network IP? So network IP, that will be, you see this ID that will remain as it is, network ID that will remain as it is, and other octaves that will be 0. So that is the lowest IP which is there with this given network ID. So that is network IP. And highest network IP of given network, that will be direct broadcast IP. So direct broadcast IP of this given network, that will be first 95 will remain as it is, then highest will be, this octave could be having 255 highest value, this octave could be having highest 255 value, right? So that is how direct broadcast IP that will be there with us. So now we are having network IP, direct broadcast IP, right? So based on this, you can understand how many hosts can be there. So number of hosts, that will be how many? You see how many bits that is there with host ID over here? 8 plus 8 plus 8, 24. So 2 to the power 24, that will be number of hosts. But out of that, 2 IPs are reserved. You see one IP that is network IP which is reserved, and second IP that is direct broadcast IP that is reserved. So 2 to the power 24 minus 2, that will be number of hosts which will be there with this class A complete network. Now once you understand how this complete network is there, we can bisect that into different size. Let me show you how. Now what I'm going to do is, I'm just bisecting this network ID with 4 segments. You see how, like you see network ID that was 95, right? And it was having host that was ranging from 95.0.0.0 to 95.255.255.255. So 2 to the power 24 minus 2, that many hosts were possible. Now what I'm going to do is, I'm going to bisect this network ID into 4 parts. And for that, you just need to be careful with this 8 bits. You see 95 that is having 8 bits, then another 8 bits will be there, then another 8 bits will be there, and then another 8 bits will be there. So this second 8 bits that we need to watch carefully. Now if you observe here, S1 that is having half of the size, right? And largest size that is there with S1. So here one thing that you need to take care of. See, if you wanted to have half size, then you can choose it by 1 bit only. If you wanted to have 1/4 of the size, then that you can choose it by 2 bits. If you wanted to have 1/8 of the size, then you can choose it by 3 bits. So here with S1, we need to have half size. So I'll be considering this first bit, that is 0 for S1 selection, right? And here as if I want to select S2, so that is having 1/4 of the size. So 1/4 of the size that can be selected by 2 bits. Now here 0 is already there for S1. So I need to have first bit as 1 and then next bit as 0. And this 2 bits, 1 0, that will select S2. Now you see S3 and S4 that is having 1/8 of the size. So 1/8 of the size that can be selected by 3 bits. Now if you observe 0 0, then 0 1, then 1 0, that is already there with S1 S2. Now if you say 1 1, then after 1 1, if I say S3 is having 1 1 0, then this will be the selection criteria for S3, and 1 1 1, that will give selection to S4, right? That is how we can select it. Now here there are few basic things that you need to understand. like if you observe, see this 0, that is subnetwork ID that you can say for S1. This 10, that is subnetwork ID for S2. This 110, that is subnetwork ID for S3. And this 111, that is subnetwork ID for S4. Right. And if you observe my previous video, in that I have explained how subnet mask can be there. Right. So subnet mask that we select as per once for network ID and subnet ID. Once for network ID and subnet ID. And that we can represent by 8/18 over here. Why? The reason is here 18 bits are 1 for subnet ID. See this 8 plus 8, 16 plus 2 bits. Right, 2 bits for subnet ID means in total 18 bits. That's why /18, that is how I have represented it. Right. So here with S1 subnet ID that is having 1 bit and 8 bits, that is there with 95. So I can say subnet mask that will be /9 over here with S1. With S2 subnet mask will be /2 bits for subnet ID and 8 bits for network ID. So that will be /10. Then with S3 3 bits for subnet ID and 8 bits for this network ID. So 3 plus 8, 11. Similarly with S4 subnet mask is 11. Now how to write subnet mask from /9, /10, /11. So here see subnet mask is what? It is also 32 bits of mask, where /9 means what? First 9 ones are there. So first 8 ones, that belongs to first octave, so 255. Then second one, and then all zeros, so that will be 128. Then all zeros are there, so 0.0. So that is what subnet mask of S1. Now as if you talk about S2, then you see 10 ones are there. So first 8 ones, that will represent 255. Then 1 means 128 plus 64, that is 192. Then all zeros are there, so 0.0. Then S3 is having 11 ones. So first 8 ones, that will be 255. The next 3 ones, that will be 192, that is 11, and then 192 plus 32. So that will be 111, and then all zeros. So 192 plus 32, that will be 224. So 224.0.0. And here also we are having 11 bit. So subnet mask of S3 and S4, that will be same, 255.224.0.0. See, this is how we can have subnet mask of all these subnets. Now very interesting part comes that explains you how we can have IP range for subnet work. How we can have IP range for subnet work. So here it is very simple. You just see for S1, see first network ID will remain same, 95. Now what will be lowest IP for S1? What will be lowest IP for S1? See, this first is 0 and then all zeros will be there. So 95.0.0.0, that will be lowest IP for S1. And it will ranges up to first network ID, that will be 95 only. Then this will be 0. Then all ones will be there. So this 7 ones, that will be 127. Then all ones means 255.255. Right. So that is how range of this subnetwork S1 will be there. Now similarly, we can have range of subnetwork S2. So in subnetwork S2, if you observe first 2 bits, that will be 10. That will be 10. Now first network ID, that is 95. Then dot, this first bit is 1. And then all zeros will be there with lowest ID. So lowest ID will be 1, then 7 zeros means 128.0.0. That will be lowest network ID of S2. And it will ranges up to highest up to 95, that is network ID. And this 10 after all ones will be there. So 10 after all ones. So see this 10, that explains you 128 plus this 6 ones will be there, that will be plus 63. So 128 plus 63, that will be 191. So 191 dot this all ones, that will be 255 dot 255. See, this is how IP range will be there with subnetwork 2. Now similarly with subnetwork 3, first host ID will be, network ID will be 95 only. Then you see first 3 bits, that is 110, and lowest ID will be having all zeros over here. So 11 and then all zeros. So 11 means 192. Then all zeros means dot 0, and it will ranges up to 95, that is network ID. Then you see 110, then all ones over here. So 110, then all ones. So you see 5 ones, that will be 31. 5 ones, that will be 31. 31 plus 192. So 31 plus 192, that will be 223, and all ones means dot 255 dot 255. Right. Now with S4, what will be lowest network ID? So 95 dot 1. You see with S4, this will be 111 over here. So 111 means 192 plus 32. So that will be 224. That will be 224. And then all zeros will be there, means dot 0, and it will ranges up to all ones over here. So 95 dot 255 dot 255 dot 255. See, this is how it will range. Now here with all the subnetworks, what will be subnetwork IP and what will be direct broadcast subnetwork IP? Let me show you how it will be there. See here, for S1 lowest IP, you see, always remember this. See, with this complete network, lowest IP, that was network IP, and highest IP of this complete network, that was direct broadcast IP. So here also lowest will be network IP of subnetwork S1, and highest will be direct broadcast IP of S1. Similarly with all. Now there can be question like how many hosts that is there with this subnetworks, right? So simply that we can find based on subnet mask given. Like you see S1, that is having how much subnet mask? 9 bits. So other than 9 bits, all the bits are there belong to host. You see how mask that we identify. See, in mask, network ID plus subnet ID, that will be provided by ones, and host ID, that is provided by zeros. So from mask, from /18/11, you can identify how many bits are there with host. See, total bits are 32 minus bits of mask, that will be bits of host, that you can say. So here with S1, how many host will be there? So number of hosts, that will be 32 bits minus 9. So 2 to the power 23, 32 minus 9, that will be 2 to the power 23 minus 2, that you need to do. Why? The reason is here 2 IPs are reserved. One is for network and second is for direct broadcast. As if you want to calculate how many hosts are there with S2. Then number of hosts with S2, that will be 2 to the power how many bits? See, S2 is having mask, that is of 10 bits. So 32 minus 10, that is 22. So 2 to the power 22 minus 2. Right. So that will be number of hosts in S2. With S3 and S4, mask is of 11 size. So 32 minus 11, that will be 2 to the power 21 minus 2. So that will be number of hosts in S3 and S4. Right. That is how we can identify. And if you say how many total host will be there? So total host will be, you see, for here it was 2 to the power 24 minus 2. So obviously here we are having 4 subnetworks. So it will be 2 to the power 24 minus 8. If you add this and this 2 times, you will be getting 2 to the power 24 minus 8. You just do it by your own, right? Now, very interesting part that I'm going to explain, like how internal router will route the frame in if frame address is given to you. So here, if you observe 3 frame addresses that is given to us, and we need to understand in which subnetwork internal router will route the frame. So we have calculated addresses, right? We have calculated addresses as per the range. So from range directly you can say in which range this address is there. But let me tell you some basic things regarding this even. Like if you observe here, 95 is there. After 95, this second octave that belongs to subnet ID. So as if you see here subnet mask ESC1. So that is having second octave that is 128. So if second octave is lower than 128, you can directly say this IP that belongs to S1, right? Why? The reason is if it is having lower than 128, which is there with respect to subnetwork, right? Then you see all the IPs that falls in the range of 0 to 127. So you can directly say, okay, this IP belongs to S1. So the frame received by this internal router that will be routed over here to S1, which is this frame, right? Now if you observe 95.188.5.7, that is how it is there. So if you observe this IP which is having second octave which is 188, if it is lower than 192, you see it belongs to S2, right? So if it is lower than 192 and higher than 128, then directly internal router will pass it on to S2. It will directly pass it on to S2. As if you observe this IP range that is there in between 95.128 to 95.191. So it falls in this range only. But when it comes to subnet, which is 244. So 244, obviously that is greater than 192. So at that time, now router will have to see which subnet mask belongs to which IP. So here we have calculated that range even, you see. With S3, that second octave range is from 192 to 223. And with S4, that second octave range is from 224 to 255. So in this situation, you will have to see. So here it is falling in between 224 to 255. So you can say 244 that belongs to S4, right? So that is how internal router that is having table based on mask, and based on mask it will route the frame, right? So as if addresses are given like this, then it will be routing frame as per explanation which I have given. So probably now you are having fair enough idea about how subnetting is done, right? So fixed size subnetting, that we have seen it in my previous video. Now I have explained you how variable size of subnets that can be created, right? So there can be varieties of questions. Probably in future coming videos I'll be solving so many examples, so that will gives you more clarity regarding how IP addresses are there and how subnetting is working in computer network. If still anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.